Unacademy format, more competitive, unified, contest for GATE ESE, specific questions, that's it.
Hello all, welcome to Unacademy. Today we will going to see our next lecture on calculus. Okay, in that we will see the double integration. In this lecture we will see the double integration whenever the integral limits are given and the integral limits are not given. Both the types we will see. Okay, before going to start this, let's see. Crack GATE ESE with India's largest learning platform. So before going to start, let me introduce myself. Myself, Dhanashree Mam. I completed my MSc in Mathematics from Mumbai University and also having 13 plus years of teaching experience. I mentored more than 10,000 plus students for the engineering. Now here how to install the Unacademy's Learning app. You can see the Unacademy's Learning app, how we install. Now here what you will get in Unacademy. So you will get the daily live classes. You can see we will get daily live classes, live test and quizzes, structured courses, unlimited access you will get in the Unacademy. Now iconic subscription, in this iconic subscriptions the most important benefit of iconic subscription is personal coach you will get in this. So where you can get one guidance from the top exam experts as your personal coach, align your preparation strategy and learning resources. Mains question and answer practice you will get, strengthen your mains answer writing through the regular practice with evaluation and personalized feedback. You will get the study tracker, participate in a study tracker plan and study booster workshops, evaluate your progress in by weekly reviews with personal coach. All benefits of plus you will get in this. Live classes from the top educators, mock test and quizzes, structured batches, courses in a line with exam syllabus. Plus subscription, you will get the plus subscription. Here daily live classes, chat with your educator, engage in discussion, ask your doubts and answer polls and all while the class is going on. Live test and quizzes, you will get evaluate your preparation with our regular mock test and quizzes and get the detailed analysis on your performance. Now you will get the structured courses. All our courses are structured in a line with your exam syllabus to help you the best prepare for it. Now unlimited access also you will get. One subscription gets you access to all our live and recorded courses to watch from the comfort of your any devices. Okay. Now learn with the top educators. Here you will see the top educators of Unacademy. Marut Tiwari sir, Ankit Goyal sir, then Sanchit Jain sir, Jaspal Singh sir. So you will get this top educators of Unacademy. Now these are some other top educators of Unacademy. Now you will get GATE and ESE courses. There are many courses are available for GATE and ESE. You can see batches and year-long courses. There are 38 courses are available for the mechanical engineering, for electrical engineering. So it means every branch of engineering, the different courses are available for you. Now, plus subscription, in short, you will get the plus subscription plan, India's best educators, interactive live classes, structured courses and PDF, live test and quizzes you will get. Now, in an iconic subscription, you will get India's best educators, interactive live classes, structured courses and PDFs you will get, live test and quizzes you will get, personal coach, you will get the personal coach. Now these are all benefits of plus you will get in iconic subscription, as well as the most important benefit is personal coach, personalized test analysis, study planner, preparatory study material you will get. No, plus plan. For the plus plan, you will get for the 12 months. If you go for the 12 months plan, it will cost you 30,250. And if the same subscription plan, you will get it for the 12 months. If you use my promo code DSP, you will get the 10% discount on your subscription plan. It will cost you 27,225. Okay, same subscription plan, it will cost you for 27,225. Now the iconic subscription, you will get the iconic subscription plan here, 12-month subscription. It will cost you 50,250. The same subscription plan, it will cost you for if you use my promo code DSP, it will cost you for 45,225. Right? The same subscription plan, it will cost you for 45,225. No, the batches are evolved. Batch is here evolved for the GATE 2022. New batch alert is already started for the civil engineering. Okay, with the top educators of Unacademy. Now the courses are already started from the 25th of January. Now to get to enroll in this batch, you can use my promo code DSP so that you will get 10% discount on your subscription fees. Now ascend for the GATE 2023 for the civil engineering for batch C, you will get a discount. To get the discount to involve in this batch or to enroll in this batch, you can use my promo code DSP to get the 10% discount. Now I'm going to tell you this discount percentage will be less. It's valid for the limited periods. So as early as possible, you can enroll your name in this batch. Okay, batch A is already started for the chemical engineering, which is already started from the 25th of January, right? So to enroll in this batch, you can use my promo code DSP to get the 10% discount. Now here batch C is already started for GATE 2023 for the mechanical engineering. To enroll in this batch, you can use my promo code, that is DSP, to evolve in this batch. Okay, now let's start our actual topic. Now we will start your syllabus here again with the calculus. In this we will see how to evaluate the integral. Okay, how to evaluate the integral. So double integrals from 0 to x, from 0 to 1. Here x square plus 3y dy dx. Right. So integral from 0 to 1 and 0 to x, from x square plus 3y dy dx. So you will get here, see, first integrate with respect to y, because these are the limits of y. right? Y is varying from 0 to x. So first integrate with respect to y. So let's start here. Let I is given integral from 0 to 1, integral from 0 to x square plus 3y dy dx, right? So you will get integral from 0 to 1. Now integrate this with respect to y. You will get x square is constant, and integrating x square with respect to y, keeping x square constant, integral of 1 dy is y plus 3 into y square by 2 from 0 to x dx, right? So which is equal to integral from 0 to 1. You will get x cube plus 3 by 2 x square minus, here y is equal to 0, so 0 dx, which is equal to integral from 0 to 1 x cube plus 3 by 2 x square dx, x raised to 4 by 4 plus 3 by 2 x cube by 3, 0 to 1, 1 by 4 plus 1 by 2 minus, here 0 by 2, so you will get here 1 by 4 plus 1 by 2 minus 0, so you will get 2 plus 4, 6 by 8, it means 6 by 8 means 3 by 4. So the correct option is 3 by 4. I hope you are getting it clearly. Double integration. Now, let's see. Next question. Integral from 0 to 2 and integral from 1 to y, yx dx dy. So these are the integral limits of x. X is varying from 1 to y, right? So first integrate with respect to x, keeping y as a constant. Okay, so let's start. Here I is equal to integral from 0 to 2, integral from 1 to y, yx dx dy. So which is equal to integral from 0 to 2. So integrating with respect to x first, keeping y constant, x square by 2 from 1 to y dy. So integral from 0 to 2 y into y square by 2 minus 1 by 2 dy, which is equal to integral from 0 to 2 y cube by 2 minus y by 2 dy. Okay, so here 1 by 2 integrating with respect to y raised to 4 by 8 minus y square by 4 from 0 to 2, 2 raised to 4. So 2 raised to 4 you will get here 2 2s are 4, 4 2s are 2, so 16, 16 by 8 minus 4 by 4, right? So here minus 0 is equal to, I think somewhere I'm wrong. Right, y cube by, oh sorry, here is y cube by 3. No, y cube by 2 from 0 to 2 minus y by 2. So you will get y cube by 2 into y by 2 dy, y raised to 4 by 4, 8. Right, here is minus 1 by 2 y square. So y square by 2 minus 1 by 2. So integral from y cube by 2 minus y by 2. So integration this with respect to y. Y raised to 4 by 8 minus y square by 2 into this 2. 4. 2 raised to 4. 2 2s are 4. 4 2s are 4. 16 by 8. So 2 minus 4 by 4. So 1. So we will get 1. Correct option is 1. But here not given. So we will use it here 1. Right? This is the correct option. Now, integral from 0 to 1, 0 to 1. Now see, you can integrate this separately also because integral limits are in constant, not in terms of variable. Okay, so we can integrate this with respect to x or y. So we will get here integral from I is equal to integral from 0 to 1. We will get dy upon 1 upon root of 1 minus y square dy into integral from 0 to 1 1 upon root of 1 minus x square dx. Right? So here direct formula you will get integral of 1 upon under root of a square minus y square. A square minus sine inverse of y. We will get sine inverse of y from 0 to 1 into sine inverse of x from 0 to 1, which is equal to sine inverse of 1. So sine inverse of 1 minus sine inverse of 0. Right? Sine inverse of 1 into sine inverse of 0 into sine inverse of 1 minus sine inverse of 0. Right? So sine inverse of 1 is pi by 2 minus sine inverse of 0 is 0. So pi by 2 minus 0, which is equal to pi square by 4. So correct option is pi square by 4. Fourth one, integral from 0 to 1 x to root x square plus y square dx dy. Right? So integral from, so first of all these are the limits of y. So we will integrate first with respect to y. So I is equal to integral from 0 to 1 integral from root x to root x to root x square plus y square dy dx, which is equal to integral from 0 to 1 integrating with respect to y. So x square y plus y square x from x to root x dx. Integral from 0 to 1 x square into root x plus root x square into x minus x cube plus x cube. Right? Integral from 0 to 1 x raised to 2 plus x raised to 1 by 2 5 by 2 x raised to 5 by 2 plus integral x raised to 2 root x is x plus integral x raised to 2 plus 2x minus 2x cube. Right? X cube plus x cube minus 2x cube. Okay. Here we are wrong. Y cube by 3. I'm extremely sorry. Here y cube by 3. So root 3 cube by 3 plus x cube by 3. Okay. So here you will get x raised to 5 by 2 plus x raised to 3 by 2 by 3 minus x cube by 3 dx, which is equal to x raised to 7 by 2 upon 7 by 2 plus x raised to 5 by 2 upon 5 by 2 minus x raised to 4 by 4 minus x raised to 4 by 12 from 0 to 1. 2 by 7 plus 2 by 15 minus 1 by 4 minus 1 by 12, which is equal to here 3 by 35. So the correct option is B. Okay. Now let's move further. Integral from 0 to 1. Integral from 0 to root of 1 plus x square dx dy upon 1 plus x square plus y square. Okay. So let's see, integrating, these are the limits of x. So y varying from 0 to root of 1 plus x square dx dy. So integrating with respect to y. So let's see. So I is equal to integral from 0 to 1. Here integral from y is equal to 0 to y is equal to root of 1 plus x square dy upon 1 plus x square plus y square dx. Right? So integrating this. So I is equal to integral from 0 to 1. So we will use let 1 plus x square is equal to a square and root of 1 plus x square is equal to a. So I is equal to integral from x is equal to 0 to 1, 0 to a dy upon a square plus y square dx. 0 to 1, that is 1 by a. Right? Tan inverse of x by a you will get. Tan inverse of y by a from 0 to a dx. Right? So you will get 1 by a constant into integral of here pi by 4 minus tan inverse of 0. Tan inverse of 1 is pi by 4 minus tan inverse of 0 is 0. Right? Dx. So integral of 0 to 1 dx. So here you will get pi by 4 integral of 1 upon root of 1 plus x square dx, which is equal to pi by 4 into log of 1 plus root 2. Here we will get 1 by a pi by 4 into log of x plus root of 1 plus x square, right? So you'll get here y by 4 log of 1 plus x square. So I is equal to log of 1 plus root 2 after substituting the limits. So the correct option is B. Now let's move further. Integral from 0 to a. Integral from 0 to root of a square minus x y square. A square minus x square minus y square dx dy. Right? Let's see. So here integral from 0 to a root of x square minus y square dx dy. So you will get integral from 0 to, first of all, these are the integral limits of x. So keeping here y constant, integrate with respect to x. So I is equal to integral from 0 to a, integral from 0 to root of a square minus y square, right, into integral of here a square minus y square is, we will treat this as b. Okay, so we will get b square minus x square dx dy. So integral from 0 to a x by 2 root of b square minus x square plus b square by 2 into sine inverse of x by b from 0 to b, right, dy. B, it means what? If we are putting b square is equal to a square minus y square, so b is equal to root of a square minus y square. So which is equal to integral from 0 to a 0 plus b square by 2 into pi by 2 minus 0 into dy, which is equal to pi by 4 into integral from 0 to a square minus y square dy, which is equal to pi by 4 into a square y minus y cube by 3 from 0 to a. So I is equal to pi a cube by 6. Correct? So the correct option is pi a cube by 6. Option A. Now see, integral of integral over r y dx dy over the area bounded by. Now see, the integral limits are not given, but here the equation of a curve is given. So we will find out this equation of the curve. Integral over r y dx dy over the area bounded by y is equal to x square and x plus y is equal to 2. Okay, so we will first of all find out the integral limits. Now see, to evaluate this integral limit, first of all we will use this, plot the curve. So y is equal to x square, standard parabola. We will get the standard parabola. Now x plus y is equal to 2. Put x0, y1, x0, y is equal to 2, y is equal to 0, x is equal to 2. Now see, this is the line. Point of intersections are, see, a of 1, 1, right? Here is b of minus 2, 4. This is y is equal to x square. That is x plus y is equal to 2. X. Right here is 0, 0. Origin. Now, to find out the integral limits, we will draw the strip. We'll draw the strip parallel to y-axis. And see where the lower end touches of the strip. That will be your. Now if we are drawing the strip parallel to y-axis, it means this is the limit. Y is equal to x square. Right? We will get the limits. Integral limits as lower end is y is equal to x square. Upper end is y is equal to 2 minus x. Right? Lower limit is y is equal to x square. Upper limit is y is equal to 2 minus x. And how the strip varying from left to right. So strip is varying from -2 to 1. Right? If you see the end point of this is -2 and here is 1. The strip is varying from left to right. So the integral limits of x are x is equal to -2 to 1. Are you getting it? So these are the integral limits. X is equal to -2 to 1. This is the limits of x. Clear? And these are the limits of y. Now, see. Now, once you get the integral limits, now it is easy to integrate. Now, see. Integral limits. Y is varying from x square to 2 minus x. And x is varying from -2 to 1. Right? Now, y dx dy. Now, integrate easily. Now, once you get the integral limits, now the integration is simple. Now, y dy. So, first integrate with respect to y. So, integral from -2 to 1. Now, integral of y is y square by 2 from x square to 2 minus x dx. Are you getting it? So, integral limits are, so we'll get here -2 to 1 y square by 2 from x square to 2 minus x dx. So integral from -2 to 1 y square, it means 2 minus x bracket square by 2 minus sorry x square by 2 dx. Right? Now -2 to 1. Now just separate out it here, or otherwise directly you can take the integration. So integral of u, that is 2 minus x bracket cube upon minus 3 into 2 minus 6. Right? Or otherwise you can take the 1 by 2 common. So here is minus 3 minus x raised to 4. It means x raised to 5 by 5 from, here is dx. Dx. Right? So put the, 1 second. Here already we took the integration. Now put the integral limits -2 to 1, which is equal to x is equal to -2 minus plus 2 4 by, which is equal to 1 by 2 into bracket. Here we will get -2 cube, okay? 4 by 3 cube, right? 4 cube by -3. 4 cube upon -3 minus 1 second. First of all, the integral limit is 1. x is equal to 1. 1 by minus 3. 1 upon minus 3 minus 1 upon 5 minus 1 by minus 3 minus 1 upon 5 minus 4 by 3 cube minus 4 cube by 3 minus 2 raised to 5 by 5 5 minus 1 by 3 minus 1 by 5 plus 64. 4 cube is 64 minus 1 is plus 64 by 3 minus 2 raised to 5 plus 2 raised to minus 2 raised to 5, this minus plus and this minus, again minus. So minus 32 by 5, right? So you will get 1 by 2 into 315 minus 99 upon 50. Make the denominator same. It is equal to 1 by 2 into 216 by 50, which is equal to 108 by 50, which is equal to 36 by 5. So the correct option is 36 by 5, option C. Okay, are you getting it? Now next, see. Integral over r xy dx dy over the area bounded by x-axis. Ordinate x is equal to 2a and parabola x square is equal to 4ay. Now again the integral limits are not given, right? So we can find out the point of intersection also. X is equal to 2a, just put it here, x is equal to 2a. So y is equal to a, you will get. Put x is equal to 2a, 4a square. 2a square is equal to 4ay. So 4a square is equal to 4ay. A square cancel out. So you will get y is equal to a. Okay. So the integral limits are x is 2a, x is equal to 2a gives y is equal to a. So the point of intersection 2a, right? So first of all we will draw the parabola. Here. X square is equal to 4ay. Right? And x is equal to 2a. This is the curve. X is equal to 2a is the line. This is the strip. We'll draw the strip parallel to y-axis. Draw the strip parallel to y-axis, right? And see the integral limits here. So lower end of y is equal to 0 to y is equal to x square, y is equal to x square by 4a. And x is varying from where to where? 0 to 2a. Right? So the integral limits also we are getting it. So same integration we will get. Here I is equal to integral limit from x is equal to 0 to 2a and y is equal to 0 to x square by 4a into xy dy dx, which is equal to integral from 0 to 2a x into y square by 2 from y is equal to 0 to x square by 4a dx, which is equal to 1 by 2 integral from 0 to 2a x into x square by 4a bracket square minus 0 dx. is equal to 1 by 2 into 1 upon a square x raised to 6 upon 96 a square from 0 to 2a, which is equal to 1 by 32 a square 64 a raised to 6 upon 6. We will get a raised to 4 by 3. Correct? So the correct option is a raised to 4 by 3. So let's see the next example. Here, integral over r, double integral over r, x square plus y square dx dy over the area of a triangle whose vertices are. Area of a triangle whose vertices are given x 0 0 0 1 1 1 1 2. So first of all we will draw the figure whatever given to you. So the vertices of a triangle, suppose this is your y-axis, this is your x coordinate, x and y coordinate, right? Now see the with 0 1, so you will get the point here, x is 0, suppose here x is 0, y is 1, so 0 1 is the point here, y is equal to 1. So here x is equal to 1, points are b11 and c12. So draw x plus y is equal to 1. This is the line x. You will get the line x minus y is equal to 1. Hmm? So you will get the equation of a line by using here points. Okay. The region bounded by, so we will see the region is bounded by a01, b11, c12. So we have to find out the equation of a line AC and AB, right? So we will see the equation of line AC. So equation of line AC, you will get y minus y1 upon x, y2 minus y1 is equal to x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus x2. That is, we will get y minus y1 is 1 upon y2 is 2 minus 1 is equal to x minus 0 upon 1 minus 0. So you will get therefore y minus 1 is equal to x, which implies x minus y is equal to minus 1. This is equation of the line AC. X minus y is equal to minus 1. Clear? Now integrating, we will integrating this with respect to y first. So draw a strip parallel to y-axis. So see here, draw a strip parallel to y-axis to get the integral limits. Now this is the strip parallel to y-axis. Now see the lower end of the y is equal to 0 to here y is equal to minus y is equal to minus 1 minus x. So we get y is equal to x plus 1 and x is varying from 0 to 1, right? So easily we will get the integral limits. So we will get I is equal to integral from 0 to 1, integral from 1 to x plus 1, y is equal to 1 to y is equal to x plus 1. So x square plus y square dy dx is equal to integral from 0 to 1 x square y plus y cube by 3 from y is equal to 1 to y is equal to x plus 1 dx. Integral from 0 to 1. X square into x plus 1 plus x plus 1 by 3 bracket cube minus x square plus 1 by 3 x cube plus x square plus x plus 1 bracket cube by 3 minus x square minus 1 by 3 x raised to 4 by 4 plus x cube by 3 plus x plus 1 bracket raised to 4 by 12 minus 1 by 3x from 0 to 1, which is equal to 1 by 4 plus 2 raised to 4 that plus x square minus x square cancel out. Only this one. 1 by 4 plus 2 raised to 4 by 12 minus 1 by 3 and minus 0. We will get 3 and here is 4. 3 plus 2 raised to 4 is 16. Minus 4 upon 12, which is equal to 15 plus 3, 15 by 12. It's equal to 5 by 4. Option B. Integral over R xy into x plus y dx dy, where R is the region bounded by y is equal to x square and y square is equal to minus x. Y is equal to x square and y square is equal to minus x. Right? So point of intersections are minus 1, 1. Here is 0, 0. Right? 0, 0 is the point of intersection. Now we will draw the strip. So always we are drawing the strip parallel to y-axis, but here we will draw the strip parallel to x-axis. We will get integral limits of x is equal to root y to x is equal to minus root y. X is equal to root y to x is equal to minus y square. Okay. So you will get here x is equal to root x. So I is equal to, let's see the integral limits here. So I is equal to, we will get the integral limits of I here y is varying from 0 to 1. So y is varying from 0 to 1. X is varying from root y to minus y square. So x square y plus xy square dx dy, right? So which is equal to integral from 0 to 1, integrating with respect to, here with respect to x first. So x cubed by 3y plus x square by 2y square from root y to minus y square dx. Integral from 0 to 1 minus y square cube into y minus y square square into y square upon 2 upon 3 minus root y square into y square upon 2 dy, which is equal to integral from y is equal to 0 to 1 minus y raised to 7 upon 3 plus y raised to 6 by 2 plus y raised to 5 by 3 minus y cubed by 2 into dy minus y raised to 8 by 24 plus y raised to 7 by 14 plus y raised to 7 by 2 into 3 into 7 by 2 minus y raised to 4 by 8 from 0 to 1, which is equal to minus 1 upon 24 plus 1 by 14 plus 2 by 21 into 1 minus 1 by 8, which is equal to 0, right? So correct option is 0. Now I hope you are getting it clearly how to find out the integration. Okay, now we will see one more example. In that case we will change the order of the integration. Okay, so let's see one question depending on this. Change the order of integration. Change the order of integration and evaluate integral from 0 to a, integral from y to a, x square upon root of x square plus y square dx dy. Okay, so originally these limits are given, x is equal to y to x is equal to 8, means originally the strip was parallel to x axis. Now we will change the order of integration. It means in this case we will draw the strip parallel to y axis to get the integral limits. Okay, now let's see. Here first we'll draw the diagram. Now here the curves are x is equal to y and x is equal to a. Now draw the strip parallel to y-axis. Y is varying from 0 to y is equal to x, right? Y is varying from 0 to x. So you will get here I is equal to integral from y is varying from 0 to x is varying from 0 to a, dx dy, x square upon root of x square plus y square into dx dy. So I is equal to integral from 0 to a, x square into Here you will get log of. Now integrating with respect to integrating with respect to y first. So log y plus root of x square plus y square from y is equal to 0 to x dx. Right? Since we know that integral of dy upon a square plus t square, which is equal to log of t plus root of a square plus t square. So I is equal to integral x varying from 0 to a x square into log of x plus root 2 x square minus log of root x square dx. So which is equal to integral from x is equal to 0 to a x square into log of x plus x root 2 minus log x dx, which is equal to integral from x is equal to 0 to a x square into log of, here we will get x plus x square log of x plus root 2 upon x dx. So which is equal to integral from 0 to a x square into log of 1 plus root 2 dx is equal to integral from log of 1 plus root x is common and integral of x cubed by 3 from 0 to a. So log of 1 plus root 2 into x cubed by 3, 0 to a. Right? Now I hope you are getting it clearly how to change the order of integration and evaluate the integral. Let's see one more example. So question number 12. Change the order and evaluate the integral from 0 to pi, integral from x to pi sin y upon y dy dx. Now here integral limits are y is equal to x to y is equal to pi. Now it means the origin is parallel to y axis. Now to change and evaluate the integration, we will draw the strip parallel to x axis. Right? Y is equal to x. Now here x is equal to pi. Y is equal to 0 to pi. Integral from x is equal to 0 to y. sin y upon y dx dy. Integral from y is equal to 0 to pi sin y upon y into x raised to 0 y dy. Integral from 0 to pi sin y upon y into y dy. Right? So y get cancelled out. So you will get integral from 0 to pi sin y dy. So integration is minus cos y from 0 to pi. So minus of cos pi minus cos 0. Cos pi is 1 minus 1. Right? Cos 0 is 1. Minus 1 minus 2 and this minus plus 2. Okay, I hope you are getting it clearly how to find out the double integration. We will see three types directly, just simple example how to find out the integral, and if the integral limits are not given, how to find out the integral limits, and then change the order of the integration. Okay, I hope it is clear to you. Okay. In the next lecture we will see the triple integration. If in the same meanwhile, if you like my videos, please do like, share and subscribe, and don't forget to use my promo code DSP, and also don't forget hit the bell icon for the further notification. Thank you so much.